Today my lecture video topic is modes of heat transfer. There are three modes of heat transfer, that is conduction, convection and radiation. Any matter which is made up of atoms and molecules has the ability to transfer heat. The atoms are in different types of motion at any time. The motion of molecules and atoms is responsible for heat or thermal energy, and every matter has this thermal energy. The more the motion of particles, more will be the heat energy. However, talking about heat transfer, it is nothing but the process of transfer of heat from a high temperature body to a lower temperature one. What is heat transfer? According to thermodynamic system, heat transfer is defined as the movement of heat across the border of the system due to a difference in temperature between the system and its surroundings. Interestingly, the difference in temperature is said to be a potential that causes the transfer of heat from one point to another. What is conduction? Conduction is defined as the process of transmission of energy from one particle of the medium to another, with the particles being in direct contact with each other. An area of higher kinetic energy transfers thermal energy towards the lower kinetic energy area. High-speed particles clash with particles moving at a low speed. As a result, slow-speed particles increase their kinetic energy. This is a typical form of heat transfer and takes place through physical contact. Conduction is also known as thermal conduction or heat conduction. The conduction equation is Q equal to del T by A, where Q is the heat transfer of heat per unit area time, K is the thermal conductivity of the body, A is the area of the heat transfer, and T hot is the temperature of hot region, T cold is the temperature of the cold region, and TL is the length. What is convection? The convection is defined as the movement of fluid molecules from higher temperature regions to lower temperature regions. The convection equation is Q equal to Hc into A into Ts minus Tf, where Q is the heat transfer per unit time, Hc is the coefficient of convective heat transfer, A is the area of heat transfer, Ts is the surface temperature, and Tf is the fluid temperature. Then radiation. Radiation heat is present in some or more than in our daily life. Thermal radiations are referred to as radiant heat. Thermal radiation is generated by the emission of electromagnetic waves. These waves carry away the energy from the emitting body. Radiation takes place through a vacuum or transparent medium, which can be either solid or liquid. Thermal radiation is the result of the random motion of molecules in matter. The movement of charged electrons and protons is responsible for the emission of electromagnetic radiation. Let us know more about radiation heat transfer. Radiation heat transfer is measured by a device known as thermocouple. A thermocouple is used for measuring the temperature. In this device, sometimes error takes place while measuring the temperature through radiation heat transfer. Radiation equation. A temperature rises, the wavelength in the spectra of the radiation emitted decreases and shorter wavelength radiations are emitted. Thermal radiations can be calculated by Stefan Boltzmann law. P equal to E into sigma A into Tr minus Tc whole power 4, where P is the net power of radiation, A is the radii of radiation, Tr is the radiated temperature, Tc is the surrounding temperature, E is the emissivity, and sigma is the Stefan constant, which is equal to 5.67 into 10 power minus 8 watt per meter square Kelvin. Radiation example. Following are the examples of radiation. One is microwave radiation emitted in the oven in an example of radiation. UV rays coming from the sun is an example of radiation. The release of alpha particles during the decaying of uranium-238 into thorium-234 is an example of radiation. The unit of heat transfer. In SI system, the unit of heat transfer is joule. In MKS system, the unit of heat transfer is calorie, and the rate of heat transfer is kilowatt.